Welcome to CSC channel, Competitive Science channel, Motion Part 3. Today we are going to discuss about acceleration. You have seen in the bike, people are giving accelerator, means acceleration. But commonly we are using as a word accelerator. It is called an accelerator, means we increase the velocity or we decrease the velocity. So acceleration means rate of change of velocity, means when you acceleration given by the accelerator, we increases or sometime we can decreases. So the rate of change of velocity is called acceleration. Acceleration is equal to change in the velocity divided by time taken, means particular time in that what the velocity is changing from the beginning is called initial velocity, at the end we call as final velocity. The difference between final velocity and initial velocity is called as change in velocity. Therefore acceleration is equal to final velocity minus initial velocity divided by time taken. So in the symbol, acceleration is A, final velocity is v, initial velocity is u, time taken is t. Therefore a is equal to v minus u by t. Coming to SI unit of acceleration is meter per second square. Example, acceleration is equal to change in the velocity. Velocity SI unit is meter per second. So time is second. So when you do the mathematical scale, it becomes meter per second square. This is a SI unit of acceleration. Two types of acceleration. Types of acceleration there. So there are three types of acceleration. One we call positive acceleration. When the acceleration is go on increasing, it is called positive acceleration. Negative acceleration, when the acceleration is go on decreasing, it is called negative acceleration. And zero acceleration, where acceleration is not at all happen. Example, if the vehicle is taken its velocity and the time, its speed or velocity is go on increasing in this rate of the graphical representation, because it is an accelerated motion, or it is called positive acceleration. Negative acceleration means again here the velocity, here the time taken. If the vehicle already it is there in the acceleration and it's coming to decreases down, because it is called decreasing acceleration or negative acceleration, or it is also called as retardation. Then in another graph, this is velocity and this is time taken. If the graph represent like this, here it is uniform velocity but the acceleration is zero. There is no rate of change of velocity. Here velocity is not changing but it is uniform, hence it is called zero acceleration. Coming to the types of equations of motion related to acceleration, we call three equations of motion. V is equal to u plus at, where v is final velocity, u is initial velocity, a means acceleration, t means time taken. S is equal to ut plus of at square, then v square is equal to u square plus 2as. These are the important equations, linear equations of motion. Then we are going to discuss the problems on these equations. Now some graphical representation of motion we can discuss now. the graphical representation. If the graph x-axis we have taken as a time, in y-axis if you have taken as a distance, it can be called as a d or s. If the graph shows like this, then it is the object at rest, because in every time the object, see, already in the time 0 the object is at 10 meter distance. So in any time the object is at the same 10 meter, it indicates the object is at rest. But here the distance, here the time taken, if the object is go on changing uniformly like this, it is called as uniform motion. Then if the distance here like this, time taken like this, if the graph it comes, this is called non-uniform motion. Coming to another graph, in a VT graph, velocity and time graph, if the objects or if the graph is like this, then it is not object at rest, it is called as uniform acceleration or uniform velocity or zero acceleration. Here the acceleration is 0, means velocity is same, so acceleration is 0. Then here the graph V and T, this is called uniform acceleration. Like this, many graphical representation will come. Thank you for viewing my video of motion part 3. Next, we are going to solve the problems. First, the problems on graphs, and next, the problems of numerical problems. We can have discussion.